I'm Margaret Mitchell. I'm a research scientist at Google. I co-lead the ethical AI team and work on fairness across Google. So actually the data, comes before the model, but before the data is the people. When you're training on data that's been curated by humans or that's based on human selection or involves humans in any way, really, you're picking up human biases. You can't just sort of output a model or output a machine learning system and then ignore it. You have to make sure that it's sort of working well, that it's not creating any sort of disproportionate harm for any particular people. Machine learning practitioners and other people sort of involved in AI, realizing that these systems are massively affecting tons and tons of people, which means any small error or any small issue is going to be propagated throughout the world, throughout anyone who's using this model or this system. Someone who is not a criminal, for example, might be recognized as someone else who is a criminal. And if these errors are happening disproportionately for Black women, that means that innocent Black women are more and more likely to be flagged as a problem as opposed to white males. So it's actually further driving systemic inequality and reifying it. It's hard to stop the progress of technology, but what we can do is try and situate that technology in a more moral framework to make sure that our development removes the effect of human biases. One of the fundamental problems, one of the fundamental things that I would like to see improved that is a very hard challenge is the culture around it and who's represented and how it's approached and who's listened to and how they're listened to. I'm Margaret Mitchell. I'm a research scientist at Google. I co-lead the ethical AI team and work on fairness across Google. I work a lot on natural language processing. I do natural language processing to computer vision, sort of interdisciplinary multimodal stuff. And then recently I work a lot on fairness and bias and the connection of AI model issues to ethics. So actually the data, comes before the model, but before the data is the people. So generally in sort of machine learning, we're using what's called supervised learning, which means that the data is annotated with some specific attributes or characteristics that you want the machine learning model to find patterns in so that it can predict things that are similar to what you've seen in that data. So that is sort of the training data that's annotated by people. And then a machine learning model is used to learn those patterns. And then from there, various outputs are produced and you evaluate it. So generally you have evaluation data that's somewhat similar to the training data, but ideally really reflective of how it's going to be deployed. And then in the whole overall life cycle, there are so many other factors that come in, like the system itself that the model is embedded in will generally have a bunch of interacting models, mixed with rules and sort of constraints and filters and things like that. And then all of this stuff sort of comes together with the help of a lot of teams and people leading research and people leading the direction of the company and things like that to create like an overall sort of system that can then be released or used by various people, and then it needs to be monitored, right? So there's a whole life cycle where you can't just sort of output a model or output a machine learning system and then ignore it. You have to make sure that it's sort of working well, that it's not creating any sort of disproportionate harm for any particular people, and if it is, update it to adjust for that. So there's been an increased interest in ethics in AI systems recently because AI systems is starting to work or are starting to work. So a few years ago, a lot of the sort of technology that we're using now were just theoretical, based on smaller data or based on sort of math that was very grounded in theory considerations and, you know, all these sort of nice theoretical guarantees. But more recently, it's been very deep learning based systems where you train on tons and tons and tons and tons of data, and then the model is something that can affect like millions or billions of people because it ends up working okay, right? So like now we can do face detection. Now we can take a picture of a bird and have a system tell us what kind of bird that is. That wasn't possible like 7 years ago. And so this rise in ethics has in a lot of ways come out of machine learning practitioners and other people sort of involved in AI realizing that these systems are massively affecting tons and tons of people, which means any small error or any small issue is going to be propagated throughout the world, throughout anyone who's using this model or this system. And when you're training on data that's been curated by humans or that's based on human selection or involves humans in any way, really, you're picking up human biases, and so this is stuff like sampling bias, which you're familiar with, like in the statistics realm, as well as things like outgroup homogeneity bias, where you're less likely to have information about people you see as other because you think that they're more general, they sort of have less nuance than kind of individuals you know a little bit better. And so what that ends up translating to is models that are making really problematic human biased decisions at scale and not having any idea that they're doing something problematic, right? So like machine learning systems can't self-reflect. They have no morality that's inherent to them. So since there's the concern and the risk and the reality of human biases encoded in the model massively affecting people, there's been a rise in how do we address this? What do we do about this? Like, it's hard to stop the progress of technology, but what we can do is try and situate that technology in a more moral framework to make sure that our development removes the effect of human biases and things like that. So I would say that ethics is not sufficient, in part because there isn't one ethics, and so if you sort of try and approach it that way, you're bound to be very myopic in what your considerations of what's ethical is. But you know, ethics provides some guidance on thinking through your values and things like that, but there are also other considerations to take into account, such as law. Or such as the aesthetics of what you're doing. You know, there's other kinds of values that we're interested in beyond ethics that also come into play within a system and how it affects people. So ethics is, I would say, necessary, but not sufficient. So one of the most famous studies recently, it was published just a couple years ago, but it's really picked up a lot of attention, is the study called Gender Shades. And what Gender Shades did was auditing of a bunch of different commercial APIs that do gender detection. It's also called gender classification or gender recognition. And when they took a look at how the errors broke down from systems that did gender classification, they found that it worked really, really well on white males and worked really, really poorly on black females. There was a huge discrepancy in the performance to the point where it basically didn't work for black females. And this has, you know, huge repercussions as we try and use this technology on people, because that means some subgroups, in this case people who are like black women and also black men, as the study found, are disproportionately affected by the kind of errors that come out. So, for example, if we're talking about face recognition, which is a huge kind of hot button issue in AI right now, what that means is someone who is not a criminal, for example, might be recognized as someone else who is a criminal. And if these errors are happening disproportionately for Black women, that means that innocent Black women are more and more likely to be flagged as a problem as opposed to white males. So it's actually further driving systemic inequality and reifying it. It's not, I wouldn't say it's inability. I mean, that seems like a bit of a negative framing, but it is blind spots. It is just a lack of awareness that we all have about things we haven't experienced before. And so what you have as systems get developed are individual developers making very, very important decisions about how this thing will work in practice. Just at the level of code, it might just be one random person just deciding that, this threshold should be there, this category should be represented in such a way. And there isn't a lot of oversight or understanding of what's going on. It's just, very in the weeds and hard to trace back once a system is deployed. So, yeah, it's a lot more about blind spots and just not having a diverse group of researchers or developers working on something so that they can bring in all these different perspectives and different things to consider. And a lot of times, the people working on developing systems are sort of white affluent males. And so that's going to encode a lot of just sort of white affluent male priorities. Not intentionally trying to discriminate or hurt anyone else. It's just that's the lived experience of a lot of developers. So, always trying to do right, oftentimes trying to be just, really open-minded, but we all have only the knowledge of the lives we've experienced, which leads to all kinds of issues in what actually gets developed. One of the really sort of basic solutions that is less exciting to people who work on machine learning has to do with data. And in general, like when you work with data and try and publish on it, like it's less likely to be accepted. It's just seen as sort of less sexy. But I would sort of kind of flip your question a little bit to say that there is a lot of focus on how to train models in certain ways to address possible skews and issues. But a lot of those things could probably be solved, and in some cases are solved, by much simpler sort of data augmentation or domain adaptation sort of approaches that have to do with how the data is represented. So there's issues in both. For example, machine learning models often use something like maximum likelihood estimation, which prefers the majority. And so just having that objective of preferring the majority is problematic. But what defines the majority is the data. So it's an interplay of both, and there's work on both with a lot more excitement in the modeling domain, even though a lot can be solved in the data domain. It really depends on the values of the company. So if the company is entirely profit-driven, sort of entirely capitalistic, then it may not prioritize moving a little bit more slowly to consider the skews, right? So there's this idea of like move fast and break things, which means that it's sort of more profitable to just quickly release things that might not work that well. But if the company's values allow for a little bit of a slower process, if they want to invest in this, in part because they care about the social impact of the work they're doing, then there's a lot more room to think about all the biases and skews and address them directly. And there's also a market case to be made, right? So like, if you can create technology that works for everyone, then you have a ton of more customers. So there's kind of one view that says, if we're trying to address everyone's needs, then we're not going to do a good job with anyone in particular. And so you're kind of decreasing accuracy overall in order to have a more fair performance across people, versus sort of doing really well for some majority cases, and then just, the long tail of other options are sort of ignored more. The sort of dichotomy that's presented between accuracy and being fair across different populations is a little bit misled. You don't have to actually sacrifice accuracy in a lot of cases, but again, that takes slowing down, thinking about what your data decisions are, and that's a monetary investment. So it depends on the values of the company, how they're going to prioritize between like short-term impact, long-term impact, how it affects society, and how driven they are by their profit margins. I think that the standards that any entity should be held to should be reflective of how many people the technology is going to affect and the sort of seriousness of the application. So I wouldn't make a distinction between sort of commercial and government. I would sort of make a distinction between affecting billions of people versus affecting a few people, and providing some fun little thing like smiling detection versus doing something like recidivism prediction, or like trying to figure out how to send police across the neighborhood in order to like maximize the chances of finding someone who's committing a crime, stuff like that. So things that are like life critical decisions, regardless of if it's coming from a commercial company or it's coming from a government, should definitely be held to a very high standard. And then things that affect just a few people versus a lot of people. As far as I've been able to understand, and this is like the work that Georgetown has done, like Claire Garvey and some others, it's like there is a lot bit of a misunderstanding of how the technology works. And so what ends up happening in practice is that the technology is applied incorrectly or used incorrectly, such that more issues come up and more sort of problems that directly affect people come out of law enforcement use or government use, because there's such a disconnect in the understanding of what the technology is doing. So like Laura Moy, also from Georgetown, has given this example of how one sort of police agency she was working with had found that face recognition wasn't working on photos they had where people's eyes were closed. And so they said, oh, to make it work, you just Photoshop eyes anywhere in, and then you can make it work. So then it works, right? There's this like binary understanding. It either works or doesn't work. And the way to make it work is often doing things that makes it not work, actually makes it create more errors. Another example, I think this came out of New York, where they decided that how to make facial recognition work the best when you had like a blurry photo or like a low resolution photo is to find a famous person who looks the most like that blurry low resolution person, and then use that famous person to scan facial database to try and find like who the criminal might be. So that's like a complete misunderstanding and obviously an oversimplification of how to how to find people that will result in innocent people being significantly harmed. There definitely needs to be more standards. I would say there needs to be a deeper understanding of how the technology works before it's deployed, and you can imagine this taking the form of trainings or something like that, educational programs that get to the basic misunderstanding, something like that. But this technology is like so new and proliferating so quickly that a lot of the knowledge is being missed in the application in the way that can be really harmful. A lot of the, I think, relevant regulation and sort of ideas of the kind of constraints you can put in place are sort of already there from less technical fields. So for example, human rights. This is already sort of established, basics of human rights, and this is something that we can also apply to our technology. We don't have to reinvent these ideas. There's actually been a lot of case law and stuff like that, also discrimination law. There's been a lot of work that comes to bear on the technology such that, you don't necessarily have to invent new things. And there are people in the sort of fairness ethics community who have been, trained as lawyers, and they get very frustrated because it's part of this tech solutionism mindset, or everything we're doing is new mindset, where they're sort of reinventing, law and ideas around law that is actually already there and has already been well considered. At the same time, there's also technology that, because it's misunderstood, either has law applied to it that is problematic, that actually creates more harm. And one of the examples there is something that's happened with GDPR, or is misunderstood to the point where there isn't the regulation in place that really should be parallel to the less technical things. So an example of the first one is, when GDPR was first released, it was a little bit unclear exactly how it would be applied. But one of the possible sort of readings from it is that you cannot ever associate someone to their gender or a predicted gender without their consent. The problem with that is that if you're trying to follow anti-discrimination law, you want to be able to say this doesn't discriminate across genders. And the way to do that is you have to get the gender, right? You can't make a guarantee about gender if you don't have gender. So this has been a big tension in trying to reach sort of ethical outcomes where we can develop, a lot more quickly than regulation comes, different techniques. So we have techniques now that can help to mitigate bias by, inferring gender and then removing that signal from the model, so the model isn't making biased gender decisions. But then we sort of have to stop doing that once GDPR comes out and says you can't do that. So that means now you have more biased models, right? Because there's that disconnect there. And then on the other side, where regulation isn't being applied, even if there's very relevant regulation in place for sort of parallel efforts, is with face recognition, where that is a biometric, like a fingerprint or like an iris scan. But because it's new and misunderstood, general constraints around biometrics are not being applied. So it's going kind of in both ways. Regulation being applied in problematic ways that is kind of because of this disconnect, and then regulation not being applied where it's relevant also because of the disconnect. So one of the issues with trying to adapt models to better address minority populations is that if you approach it with an oversampling approach, you end up forcing correlations that really oughtn't to be there. So in oversampling, one of the things to do is that you have the same kind of data instances, but then they're multiplied. So you have like a larger representation of them. And that can create these sort of artificial connections where, say for example, the data instance is like, I love the color red when I eat bananas. And then you're trying to sort of create more and more instances like this minority case in order to better fit your model to minority cases. And then you learn this correlation of red and bananas. And so now, the model sees bananas and thinks red, and that's just, some arbitrary connection that comes from misrepresentation in your data. When you're doing oversampling in the case where there's a, pool of endless data, which often isn't the case, but if somehow, that's possible, that comes against the risk of, accessing data that might be private, or that maybe people wouldn't be comfortable with you sharing. So as you try and dig through to get more data instances for underrepresented populations, you're likely to be digging into things that are poor representations of that minority population, just to get the data instances. So there's sort of a quality over quantity trade-off there. And the other thing to kind of keep in mind there is that oversampling is not something that will necessarily have your model work better on minority populations. And the reason why is because there's not a one-to-one mapping between the distributions you see in your data and how well the model will work, right? So there's this kind of naive idea that if you have equal, sort of balanced amounts of data for different populations, then your model will have a balanced output with respect to those minority populations. But what happens in reality is that oftentimes, because of various social effects, because of systemic biases and things like that, the data instances that are specifically there sort of for minority populations, or oftentimes majority populations that are just less represented in tech, end up just being more poorly represented. So you can learn poor models for minority populations even if you have equal or more data representing that population in your training data. So it's important when you're developing to check how the distributional information is affecting the output of the model and sort of update the distributions that you're sampling from based on the downstream performance. And importantly, with respect to the end task, not just with respect to the one model and how it's being evaluated on some sort of toy task, but really seeing how changing around the training data affects performance all the way downstream on the populations that you're trying to do better on. And often it's not the case that it's going to be just pure oversampling, but other kinds of techniques. Yeah, I mean, this is really an open area of research. One approach that people are looking at more and more is the idea of using synthetic data. So, for example, there has been more and more work in the area of face generation, where you learn what a face looks like. You learn sort of the attributes of a face, and then you can generate fake faces. So this is something that I think was in the news recently, where there are very, very lifelike images that look like real people, but they're all artificial. And this also is related to the deep fakes problem. So there's been some research recently on, is it possible to take a certain data set with certain distributional properties, learn sort of what a face is, and then perturb the representation of the face when you generate it so that it is somehow adding more information than just the training data itself would have added. And so that way you can kind of have similar quality across the board, especially if you're doing something like this for all populations. So you're not running into the conflated factors of systemic bias as much. But that said, like, it's, there isn't a very clear approach here that works well. There's also been work in things like transfer learning, where you, or zero-shot learning or one-shot learning, where you try and train on things that are similar and then adapt it, or take some of those representations that you learn and move it into another model in order to sort of augment it. So these are just kind of experimental techniques, but yeah, it's still an open problem. This is gonna sound like maybe a cop-out, but after working in machine learning for however many years, it's been 14 years or whatever it is, I've come to realize, or I've come to think, that one of the fundamental problems is who is at the table. And so although we can think a lot about all the sort of benefits and possibilities of technology and all the ways we can go and just really focus on the technical parts itself, the fundamental thing driving all of that is who are the decision makers and who are represented. And so a lot of the work I do within my career has nothing to do with the actual technical stuff, and has a lot more to do with bringing in people who otherwise would be overlooked, fighting for gender diversity, trying to open up paths for people, like Black women, as we talked about before, to have a seat at the table where otherwise they're just being completely marginalized. And what that does is, one, it informs what is the technology we are going to develop in the first place. Two, if there are issues with the technology that is being planned to be developed. And three, like, what kinds of considerations should we take into account throughout the model development? So although there's a lot that can be said about the directions of AI and, you know, the way that it can help in things like health and you know, just general, you know, beneficial kinds of uses. One of the fundamental problems, one of the fundamental things that I would like to see improved, that is a very hard challenge, is the culture around it and who's represented and how it's approached and who's listened to and how they're listened to.